Right, today we're going to look at solving for variables. Now, we've been talking about solving for a few days, but there are particular equations in which rearranging the variable that you are solving for can make the calculation a lot easier. So if you have multiple variables, like solving for a particular variable like height, time, or length, the equation might have all of those things in it. And so by rearranging the equation such that we get h by itself, or t by itself, or l by itself, can make it a lot easier to solve the problem. And so we're going to talk about that and what it means to solve for a variable. 8.1 says this table shows the relationship between the base length b and the area a of some parallelograms. All the parallelograms have the same height. Base length is measured in inches and area is measured in square inches. So remember, a parallelogram is a geometric shape. It's quadrilateral. It's got 4 straight sides, and the opposite sides never intersect. So the opposite sides are parallel. We use these little markings to show parallel sides. And what we're saying is a base length is the length of the bottom, essentially, and the area is essentially all the little square units that occupy the inside of this parallelogram. So all these little square units in here that make up the entire area, that fills in that entire area right there, that's what we're talking about for the total amount of area. Now, this particular parallelogram, we're saying, will always have the same height. So we might change up the base length, but this height, we're saying, is going to stay the same in the problem. So let's see if we can figure out little relationship here. So looking at the table, we did this before, and we kind of look at patterns. We're going to look at, can we go from one variable to the next, or do we see a pattern in a particular column? And I think I see both of those in this case. The columns seem to be going up by 3 here. I wonder if that is consistent all the way through. And then as I go from the base length to the area, I'm noticing, okay, each one of these, really what I'm doing is I'm multiplying by 3. I'm taking the base length times 3 and I get the area. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So maybe we can do 4 times 3 then, and we get 13.5. You notice my pattern of going up by 3 each time here is no longer true. That was true because my base length, my left side variable, was always going up by the same amount. 1, 2, 3 was going up by ones. But now we skipped up to 4.5, so we have to be a little bit careful about that. Let's pick a number. Now, my favorite number is 7. I like 7. It's my birthday is May 7th. 7 happens to be a lucky number in some cultures. So we're going to go with 7. 7 times 3 then, if I have a base length of 7 and I've got that pattern here, I'll notice that I get an area of 21 square inches. At this point, hopefully you're noticing that the height in this problem is going to end up being 3. All right, if you know how to calculate the area of a parallelogram, but we can come back to that later. All right, what if we are given the area and we got to work backwards? Well, hopefully you're doing a little bit of that mental math and saying, okay, well, all I have to do is reverse what I'm doing on the other ones. And so if I work backwards and divide by 3, I should get back to my base length. So 36 divided by 3 is 12. And likewise, 12 times 3 gets me back to 36. But working backwards, if I'm dividing by 3, 46.5 divided by 3 is 15.5. All right, so which equations from up above here would be happening, or reverse of that, decide which equation below could represent the relationships between the base length and the area. Explain your reasoning. Well, let's go through and see if each one of these would in fact work. All right, the first one is saying base length is 3 times the area. Base length equals 3 times the area. Well, since we solved for b here, and solving for b means that we've gotten b by itself, let's take a look at the area now. So if we take 3 times that area, do we get 1 for an answer? Do we get 1 for a base length? I don't think so. If we take 3 times the area here, do we get the base length of 2? No. Well, 3 times 6 would be 18, not 2. So that does not seem to work. That's not the relationship we have here. So no, if the area is multiplied by 3, we do not get base length. All right. What about the next one? Base length is area divided by 3. All right, so base length is area divided by 3. I think that's what we were doing in the last couple of problems, right? We were taking the area and dividing it by 3, and we got back to the base length. 36 divided by 3 is 12. 46.5 divided by 3 is 14.5. So yes, area divided by 3 gets us the base length. So that works. What about the next one? Area is equal to base length divided by 3. All right, that one seems to be kind of sketch because previous one essentially had that same thing and that worked, so I don't know why it would work here. Let's just check it. So if we had the base length and we're dividing it by 3, is 1 divided by 3 get us to 3? Is base length of 2 divided by 3 get us over to 6? No, that's reverse of what we were doing before. So no, base length divided by 3 is not the area. All right, and the last one, area is equal to 3 times the base length. All right, so if we were looking up top here, and that's essentially what was happening in these 3 problems, right? We're taking the base length here, base length, and multiplying it by 3, and we got the area. 2 times 3 is 6. 3 times 3 is 9. So yes, base length multiplied by 3 is the area. All right, so we talked up here about what it means to solve for a variable. I want you to notice a couple things here. We have 2 equations that work here. We've got this equation right here that works and this equation that works here. These 2 equations are equivalent to each other, right? Because we get the same result, get the same answers from both of those equations, and the answers work. So if we're solving, we get statements that work. Although they look different, they are equivalent. It's just that one has solved for the base, so in other words, gotten the base by itself and gotten the rest on the other side of the equation, while the other equation has solved for the area, so that the area is by itself, and then the other variables are on the other side. So if we wanted to know the base, we would use this little calculation here. If we were interested in knowing the area, we would use this calculation. We could use either of them for either calculation, but one would be easier because if we solve for a variable, then that makes it easier to make the calculation because the variable is by itself. We just have to do the order of operations on the other side of the equation. So solving for a particular variable sometimes is helpful.